Hello and welcome back guys. I'm Sumit Pudar and you're watching Play Chemistry. In this tutorial we will discuss the laws of chemical combination. The combination of the elements to form a compound is governed by certain laws called laws of chemical combination. The various laws of chemical combination are law of conservation of mass, law of gaseous volumes, Avogadro's law of constant composition, multiple proportions and reciprocal proportion. Law of conservation of mass. In all physical and chemical changes, the total mass of the reactant is equal to that of the product. It means there will be no increase or decrease in mass during any physical or chemical change. Physical change. Let's take a conical flask and put 250 grams of ice cubes in it. Close the opening of the conical flask with a cork. Now heat it until it changes to water completely. Now weigh it again. You will find that it is still 250 grams. There is no change in its weight. So the physical change of the ice into water is following the law of conservation of mass. Chemical change. In a chemical change, mass before and after reaction will remain same. Mass of all the reactants will be equal to the mass of all the products. So let's take an example. Put copper sulfate in a conical flask and immerse a test tube filled with sodium hydroxide in it. On mixing the both reactants completely, we will get blue precipitates of copper hydroxide and colorless liquid sodium sulfate. If the mass of the reactants copper sulfate and sodium hydroxide was like 60 grams, then the mass of the product copper hydroxide and sodium sulfate will also be 60 grams. But in some cases, the mass of the reactants is not equal to the mass of the products. Uranium, which has atomic mass of 235, changes to thorium having mass equal to 231. In this case, mass before and after is not same. There is a loss of 4 units of mass. What is happening to this lost mass? This lost mass changes to energy, and the value of the energy will be equal to mc squared, where m is the mass lost and c is the speed of light, which is equal to 3 into 10 raised to the power 8 meter per second. Now the law of conservation of mass is called law of conservation of mass and energy. According to it, mass and energy are interconvertible, but the total sum of mass and energy during any physical and chemical changes remains constant. In the former example, mass is converting to energy and sum of the mass and energy will be constant. Gay-Lussac's law of gaseous volume. Consider the x volume of gas 1 reacts with y volume of gas 2 to form z volume of gas 3. Then according to Gay-Lussac's law of gaseous volume, this x ratio y ratio z will bear a simple whole number ratio provided the condition of temperature and pressure remains same. Now let's see the statement. It says when gas reacts together, they always do so in volume, which bears simple ratio to one another and to the volume of the products, if these are also gases, provided all measurements of volume are done under similar condition of temperature and pressure. Now let's see an example. On reacting 1 volume of nitrogen with 3 volume of hydrogen, we get 2 volume of ammonia. These volumes bears a simple whole number ratio to one another and to the product, that is 1:3:2. Hence, this reaction follows law of gaseous volume. Avogadro's law. Equal volume of gases at same temperature and pressure conditions contains equal number of molecules. Let's take two systems, one with 1 volume of hydrogen and other with 1 volume of chlorine under the same condition of temperature and pressure. According to Avogadro's law, both of them will have same number of molecules. If system 1 have n molecules, then system 2 must have n molecules too. Also, the volume is directly proportional to the number of molecules. The increase in the volume implies increase in the number of molecules. In system 1, we have 1 volume of gas and in system 2 we have double of it. So system 2 will have twice the number of molecules that system 1 have. Applying it in hydrogen and chlorine reaction, 1 volume of hydrogen combines with 1 volume of chlorine to form 2 volume of hydrochloric acid. Thus, n molecule of hydrogen combines with n molecules of chlorine to form 2n molecules of hydrochloric acid. Law of constant composition. A chemical compound is always found to be made up of same elements combined together in same fixed proportion by mass. Let's take an example of carbon dioxide. Carbon dioxide has 12 grams of carbon for every 32 grams of oxygen. So in carbon dioxide, the ratio of the carbon to oxygen is 12:32. That gives 3:8. So carbon dioxide is following the law of constant composition, as it is always made up of same elements, carbon and oxygen, and always mixed in a fixed proportion of 3:8. Law of multiple proportions. When two elements combine to form two or more chemical compounds, the masses of the element which combines with a fixed mass of the other bear a simple ratio to one another. Let's take an example. Sulfur and oxygen form sulfur dioxide as well as sulfur trioxide. Every 32 gram of sulfur combines with 32 gram of oxygen in sulfur dioxide and 48 gram of oxygen in sulfur trioxide. The ratio of oxygen in both the compounds will be 32:48, which is 2:3, a simple whole number ratio. Hence, it is following the law of constant composition. Law of reciprocal proportion. Let's understand it with a diagram. We have three elements A, B and C on the vertex of the triangle. On the edge of the triangle, we have compound made up of these elements. On left hand side, we have compound formed of A and C, and on right hand side, compound of B and C. Let's take a fixed mass of C in both the compounds. Now the ratio of the masses of A and B, which combine separately with the fixed mass of the third element C, is calculated. This is the step 1. At the bottom, we have compound which is formed by direct combination of the elements A and B. Now the ratio of the masses in which A and B combine directly with each other is calculated. This is the step 2. You can observe that the ratio we get from the step 1 and 2 is same or some simple multiple. So according to the law of reciprocal proportion, the ratio of the masses of two elements A and B, which combine separately with fixed mass of the third element C, is either the same or some simple multiple ratio of the masses in which A and B combine directly with each other. Carbon and oxygen combine separately with third element hydrogen to form CH4, methane, and H2O, water. The carbon and oxygen combines directly with each other to form carbon dioxide. In methane, 4 parts of hydrogen combines with 12 parts of carbon. In water, 2 parts of hydrogen combines with 16 parts of oxygen. Thus 4 parts of hydrogen combines with 32 parts of oxygen. The ratio of the masses of the carbon and oxygen is 12:32, that is 3:8. In carbon dioxide, 12 parts of carbon combines with 32 parts of oxygen. The ratio of the carbon to oxygen in carbon dioxide will be 12:32, that is also 3:8. Hence it illustrates the law of reciprocal proportion. Guys, now Play Chemistry have a discussion page. You can post your feedback, opinion and the questions there. I will make sure I reply all of them as soon as possible. I post videos every weekend, so don't forget to subscribe. If you like this tutorial, give it a thumbs up. Thanks for watching. I will meet you next time with a new tutorial.